So in 3 dimensions, you're going to have 3 parametric equations. You're going to have one for your x, which is going to be, sorry, for the first equation, you're going to get 2 plus t. You're going to get 1 minus t. And z is equal to t. And for the other equation, you're going to get oops. Just move these over, draw a line in between. And I'm going to write my system of equations right beside them. See, yeah, because you have actually too much information, right? Because how many equations do you need to solve for one variable? You just need one. If I gave you 15 equations that all worked, you would still just need one of them. With 2 unknowns like this one, you need 2 equations. We're going to have 3. One of them is going to be redundant. One of them you won't have to use. But when you solve 2 equations, you're going to want to make sure that it also works for the 3rd equation. Because it's a possibility that you have more equations than you need, but one of them actually doesn't work. And then these lines won't be concurrent. They'd actually be skew. So we're going to find that out. We're going to solve, pick 2 of them, solve, find out what s and t are, see if it works for the 3rd one, and if it works for all of them, then we'll be able to find a point. If it doesn't work for all of them, then these 2 lines are skew. So here we've got our first equation is going to be 2 plus t equals 3 plus 2s. 1 minus t is equal to 3s. And t is equal to minus 1 minus s. I'm going to call this equation 1, equation 2, equation 3. We've used elimination so far for everything, but this one just says use substitution, please. Can you see why it's yelling that at us?
Yes, but it still not working.
Yeah, this one's already got t all by itself. So you can plug that into either equation 1 or equation 2. So we're going to plug t is equal to minus 1 minus s into which equation do you want to do? 1 or 2? 2? 2. So we have 1 minus, and then instead of t, okay, make sure you put brackets there because that negative is going to get distributed. 1 minus t equals 3s. So we get 1 plus s equals 3s. 2 is equal to 2s. S is equal to 1. S is equal to 1. If s is equal to 1, what is t? T is negative 2. Not really. Does it work for question 1, equation 1? Because if it works for all 3 of them, then we know that they intersect. When we plug in, we get 0 on this side and we get 5 on that side. Okay? So the answer is no. Because what we solved for equation 2 and 3, t would have to be negative 2 and s would be 1. But if we actually go back to our original equations and plug those things in, let's plug in 1 for t. If we plug in 1 for t, can you see that you're going to get 3 0, 1. Is that right? And if I plug in, what was S in our original? Oh, t was minus 2. Okay, t is minus 2. When I plug in minus 2 for t, I'm going to get 0, minus 2, 3, minus 2, correct? Maybe I'll make another mistake along the way. Plug in 1 for s, and we're going to get 5, 3, minus 2. Because we picked equation 2 and 3 to solve our systems of equations, what ended up happening, equation 2 and 3, we got them to be the same. But when we checked equation 1 and it didn't work, it's saying that those lines, you can only get 2 of the points the same. But the third point isn't going to be the same. So this is how we can tell this is skew. And if it does work, right, this is why you always plug it into both equations so you can say, yes, I'm for sure. I found a value of t, I found a value of s, that works.